Hi there, this is Lucius Laframboise from QESuite. I am one of the software slash. Hi, this is Lucius Laframboise from QESuite. I am part of the software sales and development team here at QESuite, and I'm here to show you a little bit about QESuite and some of the basics of how to use it. So in this video, before we even take a look at using any of the functions, we're actually going to look at some of the inputs because we've made them consistent across, and we want to make it as easy for you to get started as possible by understanding the basics. All right, so the first thing that we're going to do is we're going to click this documentation button to open up the QESuite documentation. And because QESuite is all about efficiency and doing things right, we put our documentation right here in Excel so you never have to leave if you need some help. So I'm just going to make this a little bigger and we can start taking a look. Something to note is that this is the exact same web page if you were to go to the QESuite docs page on our website, engsuite.org/QESuite/help. Same exact page, okay? And we do that because we don't want there to ever be any question as to whether or not you are getting the most accurate and up-to-date information. So it's broken up into a few parts. We have our functions, and we'll scroll down a little bit here. We've got quite a few functions, so we got a little ways to go. And then down here we have our parameters. So these are the parameters that go into the functions. And I'm just going to click this. So all of these are links to easily jump to anything you need. We also have an errors section. Right now, we're just going to look at the parameters. So this will be a little bit of a longer video because we're going to go through each one. But you can use the timestamps in the bottom to get to the parameter that you want. And we're just going to go right in order of what's on the website. These are in order in how they appear in the functions based on the modules we've broken up. So everything's broken up first by module. So you've got distributions, you've got normality, MSA, and then those modules are then subdivided by alphabetic. So it'll make sense once you see it, but just know that that's the order. It's not like this is the most important one, although data is your most important one. They go in a different order, so don't worry too much about order, okay? All right, so here we are with data. This is the first parameter we're going to look at, and it's critical because most of the time when you're using QESuite, it's because you're analyzing some data, and that's exactly what this parameter is. It's the data that you want to evaluate. It is of type number, so this is actually an array or a range. So what would happen is, just like in an average function, you select a range of data, you're going to be doing the same thing here. But they all have to be numbers. If there's something like letters or date or something that isn't a number in there, it's going to throw a value error, okay? That's different than these errors down here. Those errors down there, I'll show you in a little bit as we move on. So each of these parameter cards are broken up into a few sections. You have the name of the parameter, you've got its description, a type, required. So this is true or false. If required is true, that means it has to be in there for the function to work. And then possible errors. Not everything has a possible error. And then lastly, functions. So these are all of the functions that use this. So you can click on this and it'll take you right to that functions page, or you can do that. Pretty cool. And then down here you'll find videos. So each of these videos in the parameters will link to this video and at the timestamp of the video. Okay? So that way you can, while you're in here, even watch these videos. Kind of cool. All right, I got sidetracked there. Back to data. All right, so we're going to use capability analysis as our test. So we'll just clear this out. Just clear this out. And we're going to do equals QE.capabilityAnalysis. See, we're putting in our data here. So we have our data in this data tab. We're going to come over and we're going to select this, just like we would normally select data. Okay? Now if we hit enter, we're going to get a value because our specification is also required. So we'll get to that in a sec, but for right now, I'm just going to go add our specification. That way the function works and we can show you some stuff. Okay, so there we go. We have our data working. Let's see what happens if we have, I'm going to say hi. Let's go back into our capability. We now throw a value error. Okay, as I mentioned before, there are some errors here, and one of them is invalid non-numeric input. So that means if you input something that isn't a number. Now the problem is that Excel is expecting numbers, so if it sees something that's not a number, it's going to throw an error before QESuite even has a chance to see your data. So that means that if it's something other than a number or blank, it won't show up. But what's nice is, let's say we have 898. It works. Let's go take a look. Awesome. Our data works. Okay. Let's go over here and let's say it's actually just blank. Now we do this and we're still getting the error. Okay. So if you see that error, just make sure that you know the chances are there's something wrong there. Okay. Awesome. But what's really cool is this error won't be thrown if instead of selecting the entire row, let's say we go in here and we choose to 80. It still works, okay? So your non-numeric, so blanks can show up after all of your data. If there's a blank in the middle of the data, it will throw an error anytime you're using data. If it's outside, you will be good. Okay, another really important error that we need to talk about is this one. Error code 5003.3. Let's take a look. We're already in our errors. Not enough data points, okay? That means that you need to have 3 or more data points. So we can just go in here, change it back, and just like that, it works again, okay? So that's all you really need to know about data. We'll jump right back up to it. It's a number, a series of numbers. You have to choose a range. It is required every time it's there, and there's a couple errors to do it. All right, here we are at specification. This is the specification to evaluate against. So this shows up in the capability analysis and in Chebyshev's theorem. That's because those are two where you're checking against a specification, plus or minus, okay? So for this, we already added it. It's right here. This one is always required, and it's of type string. That means it's a series of letters. So we're going to go over here, and we select this. So we select our spec, it works. Let's say we're actually going to do a different place. Say we choose this, okay? We get error code 5003.1. So something cool about the error codes here in QESuite are you can click this button and it's going to show you some information. So it's error code 5003.1, specification not valid. Here's a help link that just takes you right here. And then a message which says, please make sure the entered value is in an accepted format. Nominal plus or minus tolerance, nominal plus minus sign tolerance, nominal plus upper tolerance / minus lower tolerance. Okay, so what that means is it has to follow these. So we're in F1, and we can do 5.892 plus / minus 0.015. And there we go, it works again. We can even do plus 0.01. There we go, it works again. Pretty cool. Gotta love that. All right, awesome. Kind of fun we got to play with that. That's it for specification. See you in the next one. All right, now we're on to our first optional parameter, name. This is the name to label your result. This one isn't important if you're just doing a quick analysis, but if you're setting up a spreadsheet, you really want to use this one because this is actually how QESuite finds the charts that it generates, deletes the old ones, and replaces them with new ones. So if you don't put in a name, it's just going to keep generating lots of graphs, and that'll just get in your way and slow everything down. So this is very, very important if this is a template or if you're going to be running a lot of analysis in it, okay? A quick little one-off, no big deal. All right, so in here, we can still stay in the capability analysis function because that's actually our next one. Dimension name or name. They're both exactly the same. So I'm going to include them both here. The only difference is dimension name is used in a couple of different functions where it's actually a dimension name rather than just a name that you're giving it. They act exactly the same, just a semantic difference, okay? There are no possible errors with this, so we really have nothing to worry about. For this, you can either type in anything you want, But we're not going to do that because that's not very realistic. You're not going to type stuff. What we're going to do is we're going to use it to select the same as our dimension name. That's why we called it dimension name. Kind of helps out a little bit, same as our specification. And now we're going to hit enter. And what's cool is you're going to see it just generated a graph with that name. So if we go up here, capability 6-pack report for 5.892 plus, that's exactly the value we put in. And we can prove that to you, okay? If we come in here and we actually change it to, let's say, G1. Oops, didn't want to do that. G1. Now you're going to get capability 6-pack report for blank because we didn't put anything in. Or we can do test or test, and that actually will show up here in the graph as well. So that's name. It's in a couple of functions, and it's very, very important when you are making templates. See you in the next one. All right, here's returnAsObject. This is a super cool one. This is a new feature that Excel just came out with and that we've included because we really think that this is really helpful. So if you remember when we had that error 5003.1, there was that little button we could push that brought up that card. So that was an object, and this gets really, really, really helpful when you have templates. So let's say you have something where you have dimension 1, dimension 2, dimension 3, and you want them all to have some sort of analysis on the top. You want to do capability analysis. You want to do distribution fitting. And you want to do it on every single column, but you don't want to have to manually do it every time. And you can't have it spilling out because now your data is spilling across multiple dimensions. Well, now you can store all of your data in a single cell simply by doing true. And bam, there you go. Super duper cool. All of your data is right here in this one cell. CP, CPK, PP, PPK. Super cool. And if you want to access any of them, you can just hit equals, click on it, and then it gives you all these options. Just double click, hit enter. Or if you know what you're looking for, you can do this. You can select it and then do dot PPK. And bam, it pulls your PPK. Pretty darn cool. It's honestly one of my favorite features of QESuite because it just expands the utility of this program so that you can now store so much data into one cell and organize it super duper easily and super well. Okay, so that one's optional. It defaults to false, which means it'll return as a spilling array. But if you put true in, it's going to return this object, and it is super cool and super helpful. All right, hideGraph. So this one is really, really useful if you don't want your graphs all the time. If you don't want your graphs to generate every time you update data or every time that you make a change to the formula, okay? This is also optional. It defaults to false, which means that it will create the graph. So hideGraph, the description is determines whether to create the graph or not. So if you have false in here, it will not create the graph. So we're going to run a little test, and we're going to name this no graph. Okay, watch, it generates no graph. Let's get rid of that. Let's change this to false, okay? It still worked. My apologies. Let's do it to true because it defaults to false. So that's another thing, is you can type false in there for either of these. And that's something I will tell you right after this. Look, no graph. Okay, something important to know about the optional parameters, if you don't want to include them, you don't have to write out false. You can just do comma, and then it will automatically take the default value, whatever it is. See, pretty cool there. So this and the last one are of type Boolean, which just means true or false. You can't just use the word true or false. You have to use the Excel, but it's really good at figuring out what you mean. So let's take a look at the next parameter. Distribution. All right, time to move on to a different module. We are going to look at our distribution identification module, okay? This one is pretty intense. There's a lot going on here. All right, so distribution is optional. Its default is normal, okay? And this is the distribution to evaluate goodness of fit. So it's of type string, and it is not required. It defaults to normal. Something to know about distribution is you have to spell things correctly. So if you're ever like, well, I don't know what distributions we have, you can do equals QE.distributions, enter, and this will return an object with all of your distributions, okay? So let's go up here and let's see. We are doing Anderson-Darling test here. So this is one. So we've already gone through data, we've already gone through name, now we're on distribution. So you can type it out manually here, or you can do something really cool, which I personally like. You can just select a value, works just fine, or we're going to use objects because they're awesome. And we're going to click on where we had that QE.distribution function, and then we can select anything we want. We're going to do 2p exponential because that's what we were already using. Just double click and bam, it works. Super duper cool. This one also has some error checking to keep it from throwing errors if it's infinity or not a number. We'll get a little bit more into that in that function, but super cool. This only shows up in Anderson, Darling, and maximum likelihood because they are capable of using all of the distributions in that QE.distributions function. Tolerance. This one is only used in the MSA module, so we're going to jump over, and we're just going to use gauge 1, okay? So in here, we are looking at the tolerance. Sorry, that's data, tolerance. Okay, so tolerance is required. We can see that down here, and it does not have the brackets. That's one way to tell if it's required. And there's a possible error, okay? That is the non-numeric input. This has to be a number, but since it's type number, it'll usually throw before QESuite ever gets a chance. What tolerance is, it's your total tolerance thread. So your upper spec limit minus your lower spec limit. So in this case, we're doing a 0.03. And then we just hit enter, and it calculates our data. Pretty cool, pretty easy. Just take your upper spec minus your lower spec. All right, reference value is only used in gauge 1, and that is why we are in the gauge 1 tab instead of the gauge R&R. So we've done tolerance, we're now on reference value. This is optional. It's a number, so just type in whatever number. It's your historical mean or whatever another measuring device that you want to evaluate against. This is what determines your bias. So if you leave this blank, it will just calculate your CG and your CGK, no bias. So you don't need it, but it can be really helpful if you want that in there. All right, awesome. That's it for reference value. Operators, this is where we're getting into gauge R&R. So gauge R&R has its own set of stuff here because it's a little different. So in here, the gauge R&R, which we'll get into this a lot more detail later in that function, but we have operators, parts, and measurements. So I'm going to hit them all here because they're basically all the same. It says type any because these can be numbers or letters here. So the operators and the parts can be any. Measurements has to be number because they're actual measurements. But these two can be, you know, operator A, B, C, operator Mike, Lucius, John. Parts can be A, B, C, 1, 2, 3, however you want them to be, okay? And these are all only used in this function, and they are all required. So to show you, we'll just go back to data, and in gauge R&R, that function has to have one entire array of operator, one of part, and one of data. So you would just select each range for each of these, and then it would sort through them, and it's going to say, okay, well, this measurement is associated with operator A, part 1, okay? And it's going to create it, and we'll get more into this in GR&R. They have to be in order of operator trial 1, parts, operator trial 2, parts. We'll get into that a little more in that video, link in the cards and the description. All right, now we are in our normality module, and we're looking at minitabFormula. And you might be saying, what does that mean? Well, when we were developing this software, we were looking through Minitab, we were looking through SPSS, we were looking through R, we were looking through academic papers to make sure that we were getting the best formulas for everything. And one interesting thing we found is that Minitab, when they calculate the Box-Cox transformation, they're not actually using a Box-Cox transformation. They're using a different power transformation. So the Box-Cox transformation is a type of power transformation, but it's a very specific one. And Minitab does a different one that they call Box-Cox. And so just to be clear, we wanted to make sure that we included both. So if you're doing a Box-Cox transformation in here, you would do your data, and then in here, true. So if you do true, it's going to be Minitab. If you do false, it's going to be a standard Box-Cox. That's the one that's actually a Box-Cox transformation. It's going to default as false. So if you look, we can just leave it blank. We can do false. But in here, when we go true, you'll look, and a Minitab and a standard Box-Cox are very different. That's because they're actually calculated differently. If you want some more information, you can go further into the documentation and actually find the formulas that are used in QESuite. But kind of an interesting thing, they both achieve the same thing, especially if you look at these graphs here. They're very, very similar, just scaled differently. They're both power transformations, just a little bit differently. All right, and we are on our last parameter, lambda. This also has to do with Box-Cox transformations. And lambda is the value that you use to transform the data. It's default, so it's optional. It defaults to the optimal value. So like in here, we have left lambda blank. That means that QESuite is going to take your data, it's going to run some analysis, and it is going to find the optimal lambda for the best distribution fit. So it's going to do, so lambda can be anywhere from -5 to 5, and it's going to find the value between -5 and 5 that leads to the best fit to the normal distribution. So I can do 1. And now we're at 4.893. So just like that, it changed it entirely. You know, and it looks pretty normal. That's because this data is normal. It looks very, very good in normality. But if we leave it blank, it'll just find the best value. And that's it. That is all that we have here in ENGSuite for parameters. So thank you so much for coming by and learning about this. Be sure to stay tuned to learn more about the functions and then learn how to really use them to amp up your data analysis in Excel. Thank you so much. Have a great day, and please do something awesome.